Lesson 81, and lesson 81 is a review of lesson 82. This is a review of a previous lesson, but the inequalities here are just a little bit more difficult to solve. This is a concept that we will visit again in Unit 9. This is Unit 9. Unit 10, we will visit this concept again in the context of absolute value inequalities. So this is something that we're introducing the concept of compound inequalities in phases. It gets a little bit more difficult as we move through. So lesson 82 deals with solving compound inequalities. Now, let's do a quick reminder of what we know so far about compound inequalities. What do you guys remember discussing previously about this? What are the two kinds of compound inequalities? Or and, right? And I think we mentioned this yesterday. Maybe we did, maybe we didn't. We actually did the compound inequality lesson on Unit 10 in honors yesterday, so this is kind of deja vu-ish for me. The or compound inequalities are union problems, okay? And the way they graph is you just graph both of them together. Because it's a union, you just slap the two solutions together on the same number line and you graph them together. These are easy, okay? So the union problems, we just graph on one number line. That's how you graph union problems, okay? So the or absolute value inequalities are the easy ones. It's possible for or problems, and we haven't gotten to this just quite yet, but it's possible for or problems to have all real numbers as their solutions, okay? It's quite possible for all real numbers to be a solution, okay? On the contrast or contrary, and problems represent what? Not union, but what's the word? We talked about where you would have to be if you were on Goodman and Getwell. You're at the intersection of the two roads. You're actually in the intersection. So the union and is looking for intersection. Union is just slap the two things together. And we're looking for intersection. So this is exclusive. And if y'all will recall, we graphed these above the number line. You graph the two inequalities above the number line, and we are looking for crossover. And it is possible, we haven't gotten there yet, it's possible for two and inequalities to have no crossover. It's possible for them to not intersect. So it's possible for no solutions when you have an and problem. So you have to be careful. You don't always just shade away from the center if you have an or problem, and you don't always just shade toward the center if you have an and problem. Sometimes they won't cross over. And sometimes or problems cross over each other completely and you shade the whole number line. So we'll see that as we continue to move forward. But that's what we've done so far with just basic inequalities. What we're going to do today is going to involve solving inequalities that are a little bit more complicated in this same context. Multi-step inequalities that are compound. All right, so let's look at the first example. X plus 3 is less than 6, or x minus 7 is greater than or equal to 1. Excuse me. X plus 3 is less than 6, or x minus 7 is greater than or equal to 1. This is an or problem, which indicates we are going to do what? We'll join the two graphs together, right? We're going to do a union. These are easy to do because if it's an or problem, hey, it doesn't matter. It's one or the others. It's both of them. Either one is good. X plus 3 is less than 6. We need to solve that by doing what? Subtract 3 from both sides, and that gives us x is less than 3. And in the second one, we need to add 7 to both sides, and that gives us x is greater than or equal to 8, right? And then we can graph these. And again, recalling that the most important part of this problem is this word right here, or. That tells us the relationship between these two inequalities. It tells us that we're going to just be joining the two inequalities together. So to graph these, we take one number line, right? And you just graph both inequalities on the same number line. So we're going to put our 3 on the graph, put our 8 on the graph. You don't have to put other numbers like that, but the 3 and the 8 do have to be in the correct position based on each other. It would be improper to put the 3 on the right side of 8 or something like that. That would be weird. Right, Mac? Sure. All right, how do you graph x is less than 3? Open circle and shade to the left. And x is greater than or equal to 8. Close circle and shade to the right. So we're just going to do both of those inequalities together on the same number line, and that's our solution.
Done this before.
We have done this before.
So it's just review.
Well, we're going to be doing a little bit more difficult problems than just this one. This problem is pretty reviewish, yes. Yes?
Are the classes like super short tomorrow? Like we'll be like being here for like a full lesson and stuff?
Gray just saw a squirrel, ladies and gentlemen. He asked an off
If the
topic.
weather's good tomorrow, I have to go.
Yes. All right. So, next example.
Hey, Robert. Chill.
3x is less than or equal to negative 6. Or x over 2 is greater than or equal to 4. Again, pretty simple problems. 3x is less than or equal to negative 6, or x over 2 is less than or equal to 4. Now, we have to be mindful always that if we multiply or divide both sides of an inequality by a negative number to flip the symbol. That's true even if you're working with a compound inequality. It's always true if you have an inequality symbol. Are we going to have that in this case? No. We do have a negative on the page. The 6 is negative, but that's not going to cause us to flip the symbol, because we're going to be dividing both sides by a positive 3, and that's going to give us x is less than or equal to, you writing this down, Carson? Negative 2. Now, how do we solve the inequality on the right?
You multiply both sides by 2.
Multiply both sides by 2, and that gives us x is greater than or equal to 8. Again, this is most important word on the page is the or. The or between the two graphs, we're just going to graph the two inequalities together on the same number line. And so that's going to be less than or equal to negative 2 or greater than or equal to 8. Less than or equal to negative 2 or greater than or equal to 8. Have I shown y'all interval notation at all? Where you use the infinities and the parentheses and brackets. Yeah, that's a concept that you'll learn a lot and use a lot in Algebra 2 and above. We'll look at it when we get to the compound inequalities in the next section of our book, next unit. All right? Try this one on your own. This is an and problem. The and problems are going to graph differently, but we solve these the same way from the outset. We have to get x by itself. Okay? Should have the inequality solved about now. What we do on the left to solve that inequality? Add 6 to both sides, and that gives us 3x is less than 12. Divide both sides by 3, and we get x is less than 4. The second inequality, we will subtract 8 from both sides. When we subtract 8 from both sides, we get 2x is greater than negative 8. And divide both sides by 2, and that gives me x is greater than negative 4. Do I have to flip the sign? I don't flip the symbol because I did not divide by a negative number. I divided by positive 2. The result was a negative number. Now, the most important word on the screen is and. This and tells me that I have to look for where these two graphs intersect. So x is less than positive 4, and we're going to graph these above the number line because we're looking for crossover. Only the part that's intersected or intersection parts will go up top. It's an open circle and shade to the left. Greater than negative 4 is an open circle and shade to the right. Do not always assume that these two things are going to just be the shaded part in between the numbers. Now, it works out that way a lot of times, so we're going to end up with just the values between negative 4 and positive 4 shaded. And that's the solution set here on the graph. That's x is less than 4 and x is greater than negative 4. We'll see in the next unit how these cannot intersect at all and have no solution. So you got to make sure that you graph it and actually look for crossover. If you don't have crossover, then you don't have a solution on an and problem. All right? I like the way this PowerPoint animates this. Is a little bit not great. This should be new, right? Have y'all seen one like this yet?
No.
Didn't think so. Another way that you can write a compound inequality is like this one. Now, do you think this would be an and problem or an or problem? It's got to be and, right? Because we're comparing this one quantity in the middle, this one thing. We're comparing this one thing to both things on the outside. So what we're really saying here is that, don't write this because we're not going to solve them this way, but what we're really saying is that negative 12 is less than or equal to 3x minus 3, and 3x minus 3 is also less than 9. Now you could separate this way and graph the two inequalities, but I'm going to show you a quicker way to do it. We can take this and work with it as it is, and we're going to still get x by itself. How would you get x by itself here? You add 3, but instead of having both sides or two sides, we really have 3 sides to this inequality, right? There's 3 pieces. So you add 3 in all 3 places. Okay? Whatever we do to one part of this inequality, we have to do to all 3 parts. It's easy enough to do this. This is not difficult. Then in each part, negative 12 plus 3 is negative 9. 3x minus 3 plus 3 just leaves us with 3x. And then 9 plus 3 is 12. One more step. Divide everything by 3. All 3 parts have to be divided by 3. Right, Billy? You doing okay? I know, man. Hey, I'm having a hard time staying awake myself. Time change and spring break both are still kicking my behind. Negative 3 is less than or equal to x, less than 4. How would we graph that? Where is x? Where are the values that we're interested in? In between -3 and +4. So the graph of this will be everything between -3 and +4, including -3 because it's equal to, not including 4 because it's just less than, and x is everything in between the two numbers. So that's what your graph will look like. Everything shaded between -3 and +4. So that's not too bad, right? Can y'all handle that? I'm going to throw in one other example like this because it's new. I think you need another one. If we had something like -15 is less than or equal to, write this down with me, 3 times 2x minus 1, which is less than or equal to 39.
Last example.
Distribute, right?
Yeah, distribute.
Is this the last example?
Now we're going to do one more. Uno más. Got a short homework assignment tonight.
Thank you very much.
So, after you distribute, what do you...
Well, after we distribute, Gray, we're going to do exactly what... Yeah, we're going to add 3 to all 3 places. So when we distribute in the middle, the outsides don't change. Only the inside is changing. So that's 6x minus 3 is less than or equal to 39. And incidentally, if we had fractions involved in an inequality like this, we would still do exactly what we always do. Multiply all 3 places by a common denominator to get rid of fractions. Now, Gray said correctly we will add 3 to both, not both sides, but all 3 sides of this inequality. That will give us -12 less than or equal to 6x less than or equal to 42.
I didn't know it was -15.
What did you write? Just positive 15?
Yeah.
It's going to change it up a bit. Then we'll do what?
Divide by...
Yeah, Caroline?
Why do you add 3?
To get rid of the -3. Remember, your ultimate goal is to get this to get this x term by itself.
Oh, okay. I wrote -6 for some reason. I thought it was -6.
Oh, 6x minus 6, you wrote the problem. Yeah, when you distribute 3 times -1 here, you get -3. All right? No worries. Then you add 3 everywhere. Then we'll divide everything by 6.
Why
Yes?
wouldn't you add 3 to 6? Yeah, I mean 6 just because it's not like...
Yeah, they're not like terms. So we're just adding 3 to each position, and it gets combined with whatever like term it'll combine with. So when you add it here in the center, it cancels these two because they're like terms. Yeah. Then divide everything by 6 here, and that will give us -2 is less than or equal to x is less than or equal to 7. How would you graph that? It's all the values between -2 and 7, right? Including those two values because it's equal to. So we'll have closed circles and shade everything in between -2 and +7. All right, get out your textbooks and turn to page 539. Page 539 in your textbooks. All right, so we're going to have a look at this. Zoologists randomly choose 5 zebras out of a herd of 20. Y'all reading along with me, please. 4 zebras weigh 540 pounds, 550 pounds, 520 pounds, and 530 pounds, respectively. What could the weight of a 5th zebra be if the average weight of all 5 zebras is between 500 pounds and 600 pounds?
550.
That was pretty quick. That would probably work, right? But is that the only weight that would work?
No, or you could do.
So
Yeah.
the tricky part of this, is that there's a range of weights that will work, and we have to set up an inequality that will work, right? First of all, let's talk about what they're asking us to do here. They're asking us to take the average of 5 things. How do you average 5 things? You add the 5 things together and divide it by 5. So what are the 5 weights? 540,
550, 520, 530, and then
550. There you go. The X is the key. You guys are great. 530 and the X here, and then we have to divide all of that by 5. Now, what are we saying about that average? We want it to be between 500 and 600 pounds. So it has to be bigger than 500, less than or equal to 600. Actually, it says just between, so we're not going to include the value, so just be less than. Because it says between. Now, I think your textbook actually does use less than or equal to, but between 2 numbers does not include the 2 numbers. So that's a technical mistake that they make in the textbook there. They're not flawless. Okay. 500. Do what?
could you make a better textbook?
Sometimes I think I could. But I don't have any plans on doing that. See, I just did the equal to again.
You can be algebra.
Hinton math. All right, so when we add those values together up top, we get 540 plus 550 plus 520 plus 530. What would that be? 2,140? 2,140 plus X over 5 is less than 600. Ignore that 3 there. That's just kind of from the white piece of paper I used so I'd have something to write on. Now, I alluded to this earlier. What would we do here to get rid of that fraction? Multiply everything by 5, and that will give us 2,500 is less than 2,140 plus X is less than 3,000. And we'll subtract 2,140 from all 3 parts, and that will give us so the 5th zebra can be anywhere between 360 pounds and, what is that, 860 pounds? That's a huge weight range, isn't it?
Yeah. How can a zebra be 800 pounds?
I don't know how big a big zebra is. I would think that a zebra could weigh 800 pounds. They're
My zebras are small zebras.
they're like horses. You have zebras?
Yes.
Oh.
Well, in my neighborhood, dude. You've been in my neighborhood. How have you not seen them?
I don't
Right
know.
when you pull into the left, there's 3.
I wasn't watching for zebras when I was in your neighborhood. Hey, Lauren.
Hey, Lauren.
All right, here we go, guys. Let's we don't need to practice any more of those. Let's have a look at the homework assignments.
You win.
There you go. No, that's not correct.
That's,
Yes, it is.
No, it's not anywhere close to correct.
that's pretty.
38 through 44.
That's actually that's my college algebra assignment. The assignment is page 540. A through D, 1 through 10, 13, and 18.
Thank you. Lauren, did you get your permit?
All right, you guys have about 7 minutes. We're going to use all of them, so keep your textbooks out. Shh. 18. Y'all listen up. Everybody listen up. Get your textbooks out.